There we go. All right, so you have a couple homework assignments different from last week. So we started the reading assignment last week. I'm going to help you finish that up today. And those of you in the classroom can't see the screen. Let's get that turned on. So I want to go through, I believe it's the last problem on the reading assignment. And then we're going to take a look at one of the homework problems that's a bit tricky. And there's some tips on doing it. You're going to set up a Google spreadsheet. So we'll take a look at that today. And then otherwise, there's time for you to work. I said I would finish all of the grading before class today. Well, that didn't quite happen. I did at least grade all of chapter 1, 2 as of 30 seconds ago. So check the grade book, see if I made any comments. There's a few people were missing some stuff and I said, please turn in the missing stuff. Or maybe I couldn't access something and I asked you to submit that. If you have any questions about the comments I made or your grade for chapter 1, 2 work, please let me know. Sam, did you get that figured out yet?
I'm gonna ask.
Okay, I can come help you in a little bit to set that up. And if you need any help getting homework done or how to submit something, let me know. I'm going to point you in the right direction. And then I want to take a quick look at an app I was playing around with the other day. I get sick of playing around with my frog and my fly thing. And a friend of mine just tested positive for COVID the other day and was really sick. And another friend got sick and died last week from COVID. People are still dying from it, unfortunately. So I made a Get the COVID app that I think that will be my final project. I'm going to keep adding to it. So I'll show you that. And that's going to lead to another thing called scalable vector graphics, which I mentioned a while ago, like on day 2, I think, when we were playing around with the Scratch editor for sprites. So we got a bunch of stuff to do. Let's get busy. So what I would like to do, oh, one other thing. I discovered a couple of people don't have the book. You can't proceed in this class without the book. I know some people are waiting for the book. So if you don't have access to chapter 3 or chapter 4, oh, I'm getting excited and losing my voice, wait. Then get in touch with me so I can get you, I don't have digital copies, but I might know someone who can send me one to borrow, or I'm just going to take pictures of my book. I've had someone that's been doing that. You got to have the book. So if you don't have it right now, you're going to be behind. Oops, sorry about that, shit. So get in touch with me if you don't have the book. If you need chapter 3, chapter 4, chapter 5, you got to get the book, right? So it's kind of illegal for me to like make copies and give them away. So I'm only doing that in emergency circumstances. If I will give those to you if you tell me, yes, you're going to get the book soon, but I can't give you the whole book by me making copies of it. That's illegal. But please, you got to have the book. What I want to take a look at right now is the house. Try it out if you haven't already done it. If you've already done it, maybe I'm going to do it a little different, maybe not. But I want to take a look at the house in terms of the idea of structured programming and the idea of finding replicated code and making so it's not replicated all over the place, that you just do it once and then reuse it. So if you don't already have the house file from the book, you can get it in your chapter scripts. I'm going to go load mine from chapter scripts right now. So first I got to log myself into Scratch. And there I am. And I have a version of it already done, but I'm just going to go with the basic one that's as the book had it. And there's a homework problem related too. So this is the practice version, which I want you to turn in. And then there's the homework version that's similar but different that you're going to turn in. So I'm going to load from my computer in my chapter scripts. Let's see, where do I put those? Downloads, chapter scripts. They should also be in your Google Drive if you can't remember where you put your chapter scripts folder on your computer. And I want chapter 4 house. Yes, I want to replace this one. And I'm just going to run it. All right, so there's my house right there. And one thing that was pointed out in the You Try It is that I think this one here is side 1. That's defined down here. And then I believe that one's side 2, defined over here. And then we have those 2 doors. Each of those are rectangles, right? So they're basically reproducing the same code by just moving, turning 90, moving, turning 90, and then repeating that twice. So side 1, side 2, and the door down here. They're all doing exactly the same thing, just with slightly different lengths and widths or bases and heights, whatever you want to call them. So what we want to do is we want to make a new procedure that we give it the width and the height or the base and the height, whatever you want to call them, And then instead of calling side one, calling side two, and calling door, we just call rectangle and tell rectangle how to draw that door or that side. Okay, so that's the goal of this right here. Then we're going to up it a notch and we're going to add windows, because windows are typically rectangles too, right? So we should just be able to throw some windows in there too. Okay, so let's do it. So if you already did it, cool, just do your own thing or check this out. I forgot to turn the chat on. Looks like no one's chatting at the moment. If you have a question, voice or chat in. All right, so I want a new block and I'm going to make, and you can call it anything you want. I'm just going to call mine rect angle. Now, when you're making variables, avoid putting spaces in them. If you need multiple words, use camel case. There's different philosophies about making variable names or procedure names. A procedure and variable kind of sort of similar. I like to write descriptive names so that I look at it and I totally get what it is. Like the word rectangle, I get it. I have friends who would rather write rect because they like to leave the name as short as possible, but still descriptive. Okay. Sometimes I look at some of my abbreviations for things later and I'm like, what is that again? So I lean toward long, but not too long. I don't worry about making it too short. So there's different philosophies, you decide. So some of my professional programmers, vibration, like again, as short a name as possible, but somewhat descriptive. Your call how to make that. So my preference would be to actually write the word rectangle. You call it box, well, whatever you want, but you got to know what it is. Now, this rectangle command needs to know what size door to make. And so I'm going to add an input here for, I like base and height, because when I think about length and width, I'm like, well, which one is that? Is it the horizontal one or the vertical one? Is the length always supposed to be longer than the width? That always confuses me. So base, I think, yeah, that's usually at the bottom. There's one of my variables. I'm going to add another variable. I'm going to call it height. But you call them what makes sense to you. Now, another thing to consider is not only these have a base and a height, but they're scaled. That was the previous variable that was going on here. So I do want to reintroduce the scale variable that was there before. So I'm going to add a third variable for the scale. And if you didn't do that the first time you tried this, you might have realized, oh shit, this isn't working quite the way I thought. Or maybe you found a way to do it without scale, but I'm just going to use scale there. And then that's all I need. If we wanted to run on the screen a little faster, we can run without refresh. We saw that a little bit last time. Thanks for Daniel's reminder. And again, what that does is normally when Scratch draws, it makes a little move and it refreshes the screen. It makes a little move and refreshes the screen. And that, takes longer. Whereas we just say, hey, do it and then show it to us. And it just does it as fast as possible. So I'm going to turn that on to make the drawing a little faster. Is that true? No, I don't. I want it to actually draw slow because something interesting is going to happen in a minute if I do this right. All right, so there's my procedure. Then I want my procedure to pretty much do what these guys do there, right? So I'm just going to basically steal side one's code, duplicate it, and stick it over here. And instead of saying 3, because this one, first one has a 3, the next one has a 9, the next one has a 1, that's one of my variables. So looking at that and thinking about the door, it does the 1, it moves 1, and then it turns 90 degrees. So it was heading to the east. Is that right? Is that way east? You guys are looking at me? Okay. Right. Is that right too? Yeah, I'm looking at the screen. It moves to the right, moves to the east, turns 90 degrees. So now it's facing up. So then it moves. So I think that's that first one's the base. Okay. So the order matters. So I'm going to just grab the word base and stick it in place of the 3. And oh, something weird happened after that. This guy. Oh, I put it. Oh, what the hell just happened? Yeah, that's where it goes. No, something got moved out of the way. Oh, I bumped the whole thing out. I see. Okay. So I don't know if you guys have ever had problems with that pushing things in the slightly wrong spot. Okay, now I got it in the right spot. So that's what should have happened. I replaced the 3 with the base, still going to turn 90, and then I'm going to replace the heights on top of 5 there. And that should be it. That should be my rectangle function, except what did I miss? I forgot to grab the repeat block. So I'm just going to grab a new one. Should have copied that the first time. I clicked in the wrong spot. All right, I'm just gonna repeat that twice. So that's it. That should be the rectangle, right? It just reproduces what the other ones were doing, but instead of giving it 3 and 5 or 9 and 5 or 1 and 2, I just say, hey, we'll give you that in a little bit. All right, so to use that, I just want to replace where I did side 1 door, side 2 door in the code with my rect and tell it what to do. So back to the blocks, I'm just going to go slide that in here. So I'm going to grab rect, and where there's a side 1, I'm just going to stick it in between there for now. And then I just need to tell it what to do. So the previous side 1 did 3 and 5. So that's what I want to go here and do and say, okay, do a base of 3 and a height of 5. And then for the scale, I just want to use whatever scale house was told to use. So I can just grab that and drop that in. And that's just going to push scale into rectangle. So rectangle will have the right scale. So we're just taking a variable and we're just passing it along. Say, okay, somebody gave me scale. I don't know what it is, but we're going to send it to this other guy to use too. So we all get to share scale. And then I just keep doing that. So now I don't need this side 1. So I'm just going to grab this change by X, slide it there. Side 1 goes to the bottom. I don't need it anymore. Bye-bye. It's gone. And I'm just going to do that for door and side 2 and door. And then we're going to try and do a window. All right. So if you already did this, how many people already did this? Just kind of curious. In the classroom, if one person already did it. All right. So the rest of you hopefully are playing along here, or you're just watching me and you're going to do it later. Okay. Some people are watching, some people are doing it. All right. And those of you online, Daniel's done. I lost the repeat block. Thank you, Daniel. I got to remember to look at the chat. Daniel's on. Good job. All right. So I'm just going to do this now. If you are playing along, make the changes as I am here. If you have questions, any questions yet? Makes sense what I'm doing? Okay. So just a note, sometimes when I get things right the first time, that means I've done it before. So when I'm programming, mostly I get things wrong the first time. Okay. So just keep that in mind. If I made it look too easy, that's because I did it before. Let's say I need a rectangle in place of the door. Door is a 1 and a 2. And it needs the scale. And then I'm just going to pop that door to the bottom and pull it away. And then I need a rect in place of side 2. I need a rect in place of the other door. And so this one, side 2 is 9 and 5. And then it needs scale. And I'm done with side 2. Grab it. Again, if you're in Zoom with me, feel free to question what I'm doing. Let's see, where to go down here. I need another door. 1, 2, scale. And I'm done with the door. And I think I made all the changes. So if I did it right, I should just be able to hit the flag and it should just draw the same house. And I don't need side 1 anymore. Bye-bye. It's always scary deleting blocks of code. Like, should I really get rid of this yet? Yeah, I guess so. Get rid of side 2, get rid of the door. They're not needed anymore. I should be able to erase it and run it again, and it all works fine. All right, next we're going to put in a window. All right, so looking at the script, the cursor starts somewhere on the screen, which is the middle of my sprite there. And then it immediately draws the 3 by 5 rectangle drawing the front of the house. It then moves X 1 scale, and then it draws the door. And then it changes X twice scale, and then it draws side 2. And then it changes X again, and it draws the other door. And then it changes X and Y and draws the roof. Okay, how does it draw the roof? Roof is a triangle, move a little bit, then draw the parallelogram. So where, looking at that chain of events with the roof last and the roof drew the parallelogram last, where do you think the sprite is right now in the picture? So it took me a minute to trace the movements to identify where it was, because we got to tell it to move to draw a window. So I'm hoping my window will be, here's my sketch of the house on my other whiteboard here. I'm hoping to get a window like over here-ish. This is my best window at the moment. Make believe it's a rectangle. And I'd like another one over here somewhere, like kind of a matching window. Ah, my pen sucks. Okay, you get the idea. So I'm hoping for 2 little rectangles over there. Anybody know where the cat ended this procedure? So think about how rects and parallelograms are drawn. So where's the parallelogram? Parallelogram moves. What's the default direction for this sprite? To the right, to the east. So it's going to move east, and then it's going to make a turn. This time it turns 120, and then it's going to move from that direction, and then it's going to turn 60. It's going to move, and it's going to repeat that, right? So I think what it has done to draw that is it's starting right here, and it's moving 9 times scale, and then it turns 180 degrees, and then it moves up this side, and then it turns 60 degrees, and then it repeats. It's facing this way, so it moves, turns, moves. I think it's right there on that corner. Okay, so that's my guess, looking at the code here. So I want it to, before it draws the rectangle, I want it to move over and down here and draw a rectangle. Okay. So I am just going to steal some other code to make that happen. I'm going to bring house up here now because that other stuff's out of the way. Get all my code a little more clustered where I can find it. All right, so let's see. I'm just going to grab this bottom block because I need to move X and Y. I'm just going to duplicate this bottom group. And instead of roof, I want another rectangle after I do that. Okay, so after I do the parallelogram, I think it's going to be at that bottom left corner of the roof, the parallelogram part of the roof, and I want it to move X, and I think I'm going to do a positive move there. So I'm going to try moving 1 and seeing what happens, 1 scale. And then Y I want to drop down, so that's going to have to be negative. So I'm going to try like -3. And then I'm going to have it draw a rectangle. I'm just going to do a 1 by 1 rectangle and scale it to fit the other stuff and see what happens. Ready, erase, draw. Oh, whoa, whoa. Wait a minute. What the hell happened? Yeah. Did it do that all the time? Draw extra lines all over the place? Yeah. Do you see any pen ups on here anywhere? No. It just throws the pen down in the middle and then moves along the borders to get to the new spot and draws something. This is the first time we've asked it to draw something that's like disconnected from the other borders.
So you might want to make an extra little tab.
Yeah, so what's that? Yeah, so we gotta figure out how we want to deal with pen up, right? So the immediate way is like, oh, it's only a problem now, so I could just squeeze a pen up before I move and then a pen down to draw it, and then we can think maybe there's a better way to do it. But then I'm gonna have to make a second window, so I have to pick the pen up again and put the pen back down. All right, so let's see. Where should that go? The command to tell it to pick the pen up and down. There's lots of ways to do it.
You could make an extra little, make your own block and
Make a block. Ooh, the projector went out again. All right, fun with technology. They supposedly left the cabinet open so I can just wiggle the cord and it might, and then it's back on. So there must be a mouse in here chewing on my cables. All right, we'll see what happens. All right, so there's lots of things I can do to make that happen. Since I'm just adding some rectangles right now, then what I'm going to do is for now, I'm just going to throw the pen up, pen down in with the rectangle command. So I'm going to add let's see, I don't want to do this. For sure, I want to put a pen down once I start drawing the rectangle. And then it's not a bad idea just to add that to any of these blocks if we want them to be located somewhere else. So it could be anytime I do a command to do something, I want to pick the pen up, put the pen down in some sequence. So I'm going to choose to do this for now. I'm going to add the pen, let's see, pen down to the triangle, the pen down to the top of the parallelogram, and the roof is just triangle and parallelogram, so I don't need it there. And then after they do their thing, I'm going to say pick the pen up, pick the pen up, pick the pen up. So each segment, I think that should be okay. put the pen down, do your thing, pick the pen up. Next guy gets his turn to move. All right, let's try that. So I want to erase and try again, see if I did a better job this time. There we go. That's a little bit better. And then I just want to do that again. So I'm just going to grab this bottom block here. I want to put a window on the other side. We can change the size and shape and position of the window. So I'm just going to duplicate, stick it underneath here. So let's see, again, the way that works is it looks like we always start in the bottom left corner of an image, one of these structures, one of these blocks, and we end up back in that same spot when we finish. So my sprite is currently on the bottom left corner of that window. So I want to tell it to move over enough to make another matching window. So I'm going to guess that's 1, 2, 3, 4 scale jumps to get there. And I don't think I need to change Y. So I'm going to try this, change by 4. And in case I screw up, I'm going to leave that there and just change by 0 and make another 1 by 1 window, erase. Oop, okay, I didn't count quite right. That happens. I'm not good with counting, although I'm pretty good at math most days. And I don't know about you guys, but when any project like this I have draw, I usually put an erase on the screen so I can get to it quick and just erase everything because I'm constantly messing around trying to figure out how to make it right. All right, let's see if that one works better. Hey, that's not bad. Little awkward. Maybe the other one should move over, and there goes the screen again. All right, you guys on Zoom, hopefully, can the Zoom people still see the screen? Did it flicker on and off for anybody besides us in the room? You guys still with me? You can still see it. Didn't blink on and off. Okay. Thank you. All right. Well, back on again. All right. I better hurry up and do some other stuff. So what's next? Questions on the house, modifying it with this rectangle block. All right. So again, I mentioned this before. If you see me do something right in class, that means I've already done it. Because usually the first time I try to do something new, it takes me a while to get it right. So do expect that everything you work on here is not going to happen right the first time. And that's the way programming works. All right, what did I say I wanted to do next? I wanted to talk about the homework number 6. All right, so I'm going to bring up my version of homework. Actually, I'm going to bring up the book's version of homework number 6. So I'm going to rename this Gary's House 2, House Gary 2, something like that. Gary's House 2, because I already did one of these the other day. All right. And then remember, for the new assignments we have this week and next week, instead of downloading this to the computer and uploading it to your Google Drive, for this week, you're just going to share this with me. That'll take you to the project page where you can type a little note here, like, yay, I added a rectangle block. Rectangle block. Simplifying the code, or maybe you don't want to say anything. All right, and then you just give me this link up here, right? If you try to give me the link without doing that share, and you try to give me that link, I'm not you, the editor, so I can't access that. Okay, so you got to make sure you hit the share first, and then you can give me the URL, and the editor does not need to be on the end. I would just get this part of the URL. Make sure you get all the digits. And then other important thing, we don't want to ever see those addresses for the most part. So a reminder about that. Let's see, this is going to go in your Google Doc. I believe I started a Google Doc for this last time. Jump into that and remind you about the way I want this assignment submitted. Activity, I don't see it there. Let's look. CS160. Chapter 4. There's my practice. And there's my house from the other day. So then for house right here, I'm just going to delete that one. Delete link. So I'm just going to link the word house there with that address I have, so I don't have to see that link. And then when I get your document, I just click it And bang, I get your house. And I can run it. All right, so next. Homework. So I'm going to upload from my computer. And if you haven't already done this, I highly recommend going and get the pressure underwater, no solution. If you've already started it, great, bring it up. All right, so we want to compute the pressure at the given depth. In this block here, we're asked to convert the Y position to depth in meters. And then I have this pressure function, this pressure procedure here that's supposed to make that calculation for me. So I just want to kind of pick this apart. To do that, I need a screenshot. So generally, to make things like this happen, when I need to play with coordinates on the screen, I draw, like, remember when I showed you my frog fly thing, I actually drew out the scratch board with the coordinates. This is something we need to do to get this one to work right. So if you haven't, at least on a piece of paper, get out a piece of paper right now, everybody. I can't programming without scribbling notes. If you try to program by just sitting at on the computer and just start typing shit and dragging blocks, that's a bad habit. You should plan stuff out. So back to that picture there. So I'm just going to attempt to draw myself a rectangle with this magic pen. So here's my scratch screen there. And I believe it's 180, 180, 240, 240. Sometimes I forget that. Yep. All right, so I'm going to draw some extra lines in here. I'm going to draw a y-axis and an x-axis, and I'm going to scale them. So we go out to 240 over there, negative 240 over here. We're at 180 up here for y and negative 180 down here. So this is the world the fish lives in. And if I look at the fish sprite, in his costume, I'm going to zoom out on that old fishy. So that's too much zoomed out. Zoom in. Okay, so this is my screen boundary right here with the brighter shading. I'm just going to use the selector. It looks like the fish is dead center in the screen according to the rectangle the fish lives in. And this is important. Images on computers are always rectangles. Even if they don't look like rectangles, they are rectangles, always. If you see a circle on the screen, that circle is really a rectangle, but you're only seeing the circular part and the corners are blending in somehow to what's going on. This fish is a rectangle and it happens to have some invisible parts on its rectangle that only expose the fish part for us. Okay, so that's something to keep in mind. So when I say the fish is centered, the rectangle the fish lives in is centered on the screen. Okay, and that is that center point that is tracked as it moves around the screen. So when we look at the fish's X position at 101 on my screen and negative 85, it is the center of his rectangle that is at that point. And there's times when we want a certain part of our sprite, not necessarily the center, to be the thing that we're keeping track of. Okay, like it could be we always want the bottom of the fish to be tracked or the bottom of the object to be tracked so that when it's at like negative 180, it's the bottom that's at negative 180, right? Not the middle of it that's at negative 180. What's that? Yeah, and you can just adjust it. Yeah, so there's plenty of ways around that, but is a sprite we get always centered on its box here? The answer is no, they're not always centered. And so if you look at different sprites that they give you, they won't always be centered. If you upload a sprite file, your own graphic file, they won't always be centered. You got to kind of check it out and decide how you want it to be. And I'll show you an example of one that's going to come in not centered in a minute. All right, so just something to know about that. All right, so let's see, back to the drawing board. In the drawing board here, what we want to have happen is we want to keep track of the depth that's going on. And based on the depth, we want to calculate the pressure. And they give us the formula for calculating the pressure. In the book, I don't have a digital copy of the book to show you right now. Let's see, chapter 4, it's 1/10 times the depth plus 1. So they're saying P for pressure equals 1/10 times the depth plus 1, right? Now, depth, if you look at the screen, the screen is all water. So I'm assuming the top of this screen, that's the top of the water that the fish lives in. So that would be 0. And then we go down from there. And on the picture in the book, they say we're going from 0 meters to 100 meters on this picture. So back here, for depth, we want to call this 0, and we want to call this 100. The red numbers I drew, they're the y coordinate. So somehow what I have to get to happen is this y coordinate of 180, I want that to be recalculated as 0, and this y coordinate of negative 180, I want that to be redone as 100. Well, there's a lot of ways to make that happen. And what I was thinking when I first saw this was, well, I know that 0 for y is already right in the middle. So all I need to do is shift so that 0 goes over to there instead of in the middle. Okay, so and how far is this distance right here? That shift. It's 180, yeah. So we want to basically do a shift of 180 to put 0 up there. Okay, so when I get a y coordinate of 180, I want it to be called 0. So wouldn't you agree that if somebody says, hey, y is 180, if I want to shift to make it 0, I'm just going to subtract 180 from it. That makes sense? All right, so here's what's happening, right? Somebody throws at me y equals 180. Now they're going to throw other y values at me too, because the fish is going to be moving around. So the computer screen, and I want to transform that into 0. D equals 0. It's supposed to be D equals 0. And I think to make that happen, I'm just going to do a y minus 180. What's 180 minus 180? 0. That works pretty good. And then if they threw at me y equals 0, then my little formula here is going to take 0 minus 180, and that's going to be called depth negative 180. Right. And then if they throw the bottom depth here, the bottom y value, y equals, sorry, my pen skills are not very good here, y equals negative 180. My formula says to take whatever y they give me and subtract 180. What is my formula going to spit out? Depth equals, no, that's going to be negative 180 minus 180. Negative 180 minus 180. So I lost 180 and then I'm losing 180 again. So I've totally lost 360. Yeah. So I'm going to redo that scale to be negative 360. So now by doing the y minus 180, I've retransformed this to give me a number from 0 to negative 360. So I got part of what I wanted to have happen. What did I want to have happen? I wanted 0 to be at the top. I got that. Now I have to figure out how to change that negative 360. I want it to be 100. So now I got to change that. So this is getting a little messy. So I'm just going to go over to a new screen here. Oh, no, I want to go back a screen. This one right here. So reminder, on this screen right here, we have a scale from positive 180 down here to negative 180. And we are going to transform that. And it's about time to move into the spreadsheet to do this. So we can see a whole bunch of numbers change. We're going to transform that by just subtracting that y value. We're going to take away 180. And that's going to give me a new scale that goes from 0 to negative 360. What do I really want that to look like? Well, I'd rather have that be 0. I like that for the depth. But down here, I want it to be 100. Okay, let's see what's going on in the middle. That number might help too. In the middle, I had 0. We transform that. So 0, that should be red because it's a y value. And then I'm going to transform that by subtracting 180, and that's going to give me negative 180. And then what do I really want that to be for depth? 50. All right. So I want to get rid of the negative, so I'm going to have to multiply by a negative. Agreed? Yeah, and when we change scale, that's a multiplication. Like think about the house problem we looked at a minute ago. They were resizing the movements on the house by multiplying by some scale. Right, so that's how you redo a distance. You multiply it by something. So we want to multiply something to turn negative 360 into 100. So I'm just going to write a little formula here, a little math. I want to take negative 360 and I want to multiply it by something so that the answer is 100. So here's how I make that happen. We're multiplying here, right? I need to turn a negative into a positive, so for sure I need to multiply by a negative. I want the 360 to go away, so I got to divide by it to get rid of it. And what do I want to see there instead? 100. So my claim is if we multiply by negative 100 over 360, we're going to get 100. Right? Get rid of the 360, we divide by it, multiply by the fraction, multiply by a negative, we want it to be 100. Let's see what happens if we try that on the negative 180 here. What if we take negative 180 and we multiply it by this same fraction, negative 100 over 360? What happens? 180 and 360, that goes in twice. 2 goes into 100 50 times. Negative times a negative is a positive. Is that what I'm hoping it'll be? Okay, let's test it on a spreadsheet. So I asked for this problem that you build a spreadsheet to help make sure they're getting the calculation right. So let's bring up the next exercise. So we want to build this spreadsheet right here. So I want to take the y coordinate. Now here it says to go from 0 to 360. We can do that. And then we want the depth of 100. So let's see. I'm just going to try and copy. Is that a picture of a table? Nope. There we go. I can copy those. Ooh, it doesn't want to copy that one. All right, fine. I'm trying to copy because I don't like to type if I don't have to. All right, Google Drive, chapter 4. We need a new spreadsheet. New sheet. If you haven't already made it, please do. And let's see, we told to give this a name somewhere here. I don't see where it says to give it a name. Problem 6. Okay, there we go. All right, so my y coordinate starts at 180 and then drops down. And let's see, what did we say to do here? 180, 150, 120. I think that's a fixed pattern. Dropping by 30. So remember I showed how to fill numbers before, so I can just highlight 180, 150, let go of the mouse, point to the bottom right corner, fill it down, and there's negative 180 down there. Okay, so I turned it from 0 to negative 360 by doing y minus 180. If we want to change the sign, we could just do 180 minus y. To type a formula, to do a calculation, you have to type equals first. And to get the positive version, I should just be able to reverse the subtraction. So 180 minus, now I can't type y because the computer has no idea what y is. Where do my y values live? Right next door. So just click on the box next door. Google will say, do you want to fill that down? I hit check for yes. And then Google calculates, you're now going from 0 to 360. Cool, modified version of my first attempt. All right, next we need to scale those to go from 0 to 100. And with my little bit of algebra back here, I claimed I could do that by just dividing the 360 out and multiplying the 100 in, and that'll give me the scale I want. Okay, just a proportion. One of the most powerful things in mathematics, proportions. Now I don't have to worry about the negative because I already dealt with that by reversing the subtraction. So I should just be able to type 100 over 360. Now, how many people love reducing fractions? Feel free to reduce it. I don't care. Do I have to reduce it?
No.
No, it'll still work. You could reduce it down to, I can't remember what it does, but it reduces quite a bit. I guess I can show you how to reduce if you forgot.
Is it 100?
So what, yeah, so to get the change the sign, I did a 180 minus y instead. Yeah, so my first attempt at it on the whiteboard, I did y minus 180, that gave me negative numbers. To change subtraction, you change the direction of subtraction, it always changes the sign, right? 4 minus 3 is 1, 3 minus 4 is negative 1. So all I had to do is switch the subtraction. Now, what do I have to do first to calculate the depth? Type equals. What? Type equals, right? Yeah, got to do type equals first. And then here we're just going to simply take 100, divide by 360, and multiply it by our 0 to 360 number. Could you multiply then divide? Sure. Either way. But the 360 has to be the one that gets divided. Enter. Google says, hey, can I fill that for you? Oh, thank you, Google. Absolutely. And oh, there it is, 100.
Okay.
Maybe. If that didn't work for you, if you have a question, if I went over something too fast, let me know.
Highlight why I'm still stuck on it.
Okay, so I'm just going to delete all this. I'm going to delete everything. Except my titles. I don't want to type those again. Delete. Okay. So on the problem assignment, I said make a list starting with 180 and then 150, and then it goes to 120, which is dropping by 30. Spreadsheets will automatically fill a pattern you start that's equally spaced. You just highlight the pattern, move the mouse, point to the bottom right corner, then click and drag. It is a two-step process. Drag that down until you get your negative 180. Then this formula right here, the first time I did it, I did the y minus 180. That gave me negatives. So I decided to reverse it to get positives. So that means I want to do 180 minus y. Where do my y values live? Right there. So I just click on the next y value, hit enter. Google says, do you want to fill down? Sometimes I accidentally hit enter. I'm like, shit, what happened? Didn't fill down. I had to hit the checkbox. So if you missed out on the Google automatically filling down for you, click back on the formula and drag just that formula down, and it'll repeat that calculation over and over, always grabbing the y value to the left. I have left and right, yes, left. For the depth, we decided we could just multiply by the ratio 100 over 360 to convert that 0 to 360 scale to a 0 to 100 scale. So equals to start off with, and then I'm going to take 100 over 360, which you can reduce if that's freaking you out. I'm just going to leave it because I think those are two beautiful numbers. And I'm going to multiply by the 0 to 360 number. Enter. Google says, may I fill that for you? I'm going to hit the check this time. And Google automatically copied that formula down for me. And so if I double check like the third one down, it's going to say, grab whatever's number is to the left of me and multiply by 100 over 360. And then I got the number I want. Oops, I accidentally deleted it. Undo, there we go. And so now I have my 0 to 100 scale to match the y coordinates 180 to negative 180. Last, I need to calculate the pressure, and they gave me the formula for that. They said take 1/10 times the depth from 0 to 100. It's got to be in meters, and then add 1 to it. One, and those are in atmospheres. 1 atmosphere is the pressure around you at sea level. Okay. So we're in Pendleton right now. There's people in the group. We're pretty close to sea level. So the pressure around us right now is 1 atmosphere, roughly. We're going to adjust this for underwater by multiplying 1/10 times the depth in meters to the left, and then adding 1 to that. Oops, and I hit the wrong button. How do I fix that? I click on my formula and then I drag the formula down. All right, so if anybody gets stuck on any of those steps, let me know. Garrett, you're looking at me, like you got a question. Okay. That's okay. So again, my first formula for the 0 to 360 just says take whatever cell is next to me and take it away from 180. The next formula says take whatever cell is to the left of me and multiply by 100 over 360. And the last one says, oops, take whatever is in the cell next to me to the left and multiply by 0.1, then add 1. Okay. So that's the calculation that needs to happen in Scratch. The next bit of fun I'm going to leave up to you is how do you tell Scratch to do that? Okay. And I recommend doing it in 2 steps. And the project kind of implies you should do it in 2 steps. The pressure function is expecting a depth in meters. So the pressure function here is expecting to get the numbers from this column right there. So that needs to get calculated. And then the pressure function just does that. Yeah, so I'm going to leave that up to you to try and implement that in Scratch. If you get stuck doing it, be sure to message me or wave your hand at me later and say, I tried it a few times. It's not quite giving me the numbers my spreadsheet is. Once it's implemented, what should happen is as your fish goes around the screen, it should say the correct pressure. And how do we know what the correct pressure should be? Well, when the middle of the fish goes at the middle of the screen, what I should hear it or see it say is the pressure should be 6 right there. Okay, so if you do your calculation and when the fish passes right in the middle there, it doesn't say 6, it says some number that's nowhere near 6, something went wrong in your calculation. Okay, will the fish ever get all the way to the top of the screen? No, because he's on edge bounce. So his upper fin will hit the top of the screen, but we're tracking his center line. And so he's always going to be a little bit below. So we'll never get quite to a pressure of 1 at the top. It'll be a little more than 1. And at the bottom, he's never going to get to the bottom because he's bouncing off the edge. So we'll never quite get to 11. So what you should see, though, are pressures that are roughly between like 1.8-ish and 10.2-ish with a 6 right in the middle if you put all your calculations together correctly. Okay. All right. So I got 2 more things to talk about, and then you're just going to get stuff done, and I'm going to answer questions as necessary. I want to show you the start of my COVID app, which I think is going to be my final project based on my recent inspiration. Oh, and this is really weird. So it hit me last night, right? A friend got sick, they got COVID, but they're going to be okay. They were vaccinated. Another friend gets sick, unvaccinated. They died in like 3 days. And then after I stayed up late playing around with this last night, and I finally went to bed, and my stepdad came to see me in my dream to talk to me about programming, and he died of COVID last spring break. It's like, whoa, this is weird, right? Your mind does weird things. He didn't really come visit me, right? I was dreaming about it. But I'm making a COVID app. I'm going to do something weird with COVID. I don't know what yet. Well, I have an idea. I'm going to show you my idea. And I don't know where it's going to go. So the house number 4 in the homework, not the practice, but we did the practice house, right? In the homework assignment, there's another house that's going to be a lot like the house we made. So you can use what we made with the practice house to do the homework house. Okay, so that shouldn't be too bad. There's one to convert Celsius to Fahrenheit in a procedure, right? We did Fahrenheit to Celsius back in chapter 1. So we're just going to reverse that calculation in a procedure for here. And then what's the other problem? You're going to write your name with however many letters you need, right? So if I go with my last name, Parker, Parker, A, I get to use twice. No, I only got 1 A. Well, in Rhode Island, it's Paca, right? We don't, so in Rhode Island, like it should be 2 A's, but anyway, 2 R's, there we go. So the R I get to use, I don't have to make again. So if you have a really long name, if you have a shorter nickname, go for it, okay? But just a 1-letter name, please at least use 2 letters, is my hope, okay? If you have a super long name and you really want to make all those letters, that's fine, okay? And you can have multiple sprites make the letters, or you can have just one sprite with multiple procedures make the letters you choose, right? So those are your homework assignments. Let's take a quick look at my app. So if you go to the home page, at the top are the announcements. When I share things I make, I think I'm probably going to be putting them in for announcements in the future. So last class, I shared with you my broadcast demo, which was just kind of a cheesy thing to show the difference between broadcast and wait versus broadcast. Now I added my Dr. P fights COVID there. So that's the new one I'm working on. If you want to check that out, I want to just show a couple things about it. Once you choose share on your app, it jumps you to the project screen and basically says, hey, do you want to say, oh, I didn't save my last version, shit. I've been having trouble. My work has not been getting saved all the time. I say that because I added some credits here for where I got this Dr. P and where I got my COVID. So I'll put those back in. But beware, every once in a while, I've been having trouble where Scratch has not been saving when I think it should. So make sure you download anytime it looks like Scratch isn't working right or saving things, download it just to be sure. So I have a backup somewhere. So anyway, it says Dr. P is fighting off COVID viruses. You can move him with the arrow keys, put up his COVID force shield by pressing S for shield, and then press the space bar to launch COVID vaccines out there. And I'm just going to blow it up and run it. So it's pretty minimal right now. The COVID start jumping around the screen. You notice some of the behavior. What's triggering him?
No,
Yeah, when the COVIDs hit him, he goes, ah, I'm gonna eat you. I'm a monster. But he doesn't necessarily get them though. Did you see that? Sometimes he does and sometimes he doesn't. Oh, that one flew right into his mouth. Good job. He's very heavily vaccinated, by the way. He's not going to die of COVID. So I'm just going to take a quick look inside and show you what I did so far. I got a lot more work to do. And then I'll show you one of the graphics that I put together. So I made a procedure called draw. I'm calling it draw net. I don't know why I called it draw net. That was like midnight last night. But I use it in a couple of places. I use it when I press the space key, and I use it when I press the shield key. And oh, I forgot to press space when you guys were looking at it. If once I run it, if I press space, then he's going to throw a vaccine out, and the vaccine is just move. Oh, I forgot to use arrows to move. There's just some random polygon I have him draw. But notice that the polygons also kill the vaccine. Okay. And then if I want him to draw his shield or shield up, then he draws one of his nets around himself and gets in the middle, so the COVID can't get him. So some things I'm going to have happen later is I'm going to add some tracking for both the COVIDs and him, so that when he kills a COVID, he should get credit for it. But if he gets hit by too many COVIDs, that might weaken him, right? Even if you're vaccinated, like you might not get COVID, but you just might get a lower, just less symptoms, right? So somehow I want him to be like a little slowed down if too many COVIDs hit him, right? So I got to add that functionality in later. What else do I want to say for it? The big thing about it was, you know, I defined a procedure that I'm using multiple times. Otherwise, all of this code right here would need to be both in this block and in that block, and we don't want to do that, right? Whenever we have repeated code, we want to put it in a procedure that we can then reuse the procedure, so we don't have to retype and re-edit the same amount of code over and over again. The COVID vaccine, I want to share a couple things about this one. It's pretty simple. I just say, hey, make a bunch of clones of the original one. And then when I start as a clone, start whipping around the screen. And then if I happen to touch red, what red might the COVID be touching? The mouth and the force shields and the COVID, the vaccines are red. So when the vaccine hits those, they die and they get chomped. The costume is what I wanted to show you here. So I had forgotten about this and rediscovered it when I was playing with you a couple of weeks ago. When you draw in the sprite editor, it makes what are called scalable vector graphics. So for example, this red thing right here isn't actually paint necessarily. It's an actual equation for a circle. That circle has a center and a radius, like we define them in algebra. And I just told the computer to make a circle with that radius and stick it right there. Scalable vector graphics are just math equations that say, hey, draw a circle, draw a line, draw a squiggly shape. There's a way to talk to make squiggly shapes. And I think they're fascinating because I like math and I like computers. So I just wanted to show you an example of let's see, where do I put it in here? What a scalable vector graphic file looks like before the computer draws it for you. And I'm going to add this to that, let's get the link to that announcement I made right now. So let's reply to that. COVID SVG. Link it. So if you're curious about scalable vector graphics, here's a sample that you can download and play around with. And there's lots of websites that teach you about SVG if you ever want to learn more. I think they're fascinating. Let me show you this one. Where'd it go? Here, done. I got to download it to view it. Don't think I can edit SVGs directly in Google. Open with, sure, we can open it in Firefox. So Firefox will see, oh, this is an SVG file, and Firefox will draw it for me. If Firefox can load today. What happened to it? Did it go on a different screen? Hello, Firefox, where'd you go? Oh, it's still thinking about it. Oh, is it going to open in Edge instead? Nope, there's Firefox. Okay, so there's my image, not now. Oops, a little bit got clipped there. I'll have to figure out why later. And then to view it, I'm just going to go right click and inspect and then show you what the code looks like. It's a little bit messy. Let's blow that up a touch. Let's actually pop that into a new screen. Pop in a new screen button, separate window. There we go. Again. So this is what an SVG file looks like in the background. The computer just draws it. So basically I tell it, starting at 0, 0, make me a box that's 50 by 50. And then I said, scale it up to 400 by 400. And then I said, draw me a circle with a center of 25, center of 25, and a radius of 22. The stroke is the pen that draws it. And I said, give me a stroke color of that. I'll explain that later. Make the width of it 2 and make the fill, the inside transparent. And basically, I'm just drawing a whole bunch of circles. Now, to position them right, I decided instead of moving them X and Y, I decided to rotate them around because I was trying to orient them around a big circle, the big green circle. So I have some rotations going on here, and I can explain that to anybody another time if you want to know more. My point is, in Scratch, and somebody might say, well, why would you do that to yourself? Okay. Usually you don't have to look at the code. I do it just because I'm a geeky math person and I think it's geeky fun. But the Scratch editor, when you draw something in Scratch, it basically writes all of those kind of equation type things. And this is the result of it right there. All of those circle commands I did built that right there. And a lot of times, like images could be bitmaps, which is pixel by pixel graphics, kind of like taking a photograph, but they could also be just a bunch of shapes, mathematical shapes. Like this guy right here was actually a bunch of mathematical shapes. He was too complicated for Scratch to deal with, so I had to make him into what's called a bitmap image, a PNG. But a lot of images these days are what are called vector graphics. What's good about vector graphics? Well, if you take a graphic like this guy right here, and you start making him bigger, like when we zoom in on him, what happens to the edge of him? He pixelates, right? He gets blocky. Scalable vector graphics don't do that because the computer has an equation to redraw it every time, and it's always going to be smooth.
But there's always going to be.
So if I zoom in on the circle here, it's never going to pixelate. Well, that's not true. There are pixels on the screen, they're just wicked tiny. But notice as I zoom in on this one, it's staying pretty good. My only hindrance is the resolution of the screen. Okay, so that's why they're called scalable vector graphics for a reason. When you zoom in and out on them, the computer always redraws them to look as good as possible. That doesn't happen with bitmap images like this guy here.
Although some aesthetics would change to keep it
Yeah. Well, and it depends, like some images, it can be more work to have it be a mathematical image than a bitmap image, but other images are the other way around. It can be cheaper computationally to have the mathematical image than it can have the bitmap image. And it just depends on the image. Yeah, so I'm not saying scalable vector graphics are best for everything, but they do have a big use in computer graphics these days. All right, so that's it for now. I'm gonna shut up. It's 3 o'clock-ish. So you know your mission to finish the practice problems and then to get working on the homework problems. If you need any help with any of those, let me know. And you should start thinking about your final project soon. You don't have to decide today, but I know a few people have already started working on their final projects. So this is my little thing saying, I'm working on mine now. I'm going to keep working on it every week. But I'm going to just keep doing my homework too, like you guys. All right, that's it. I'm going to shut up and then you guys just do stuff and let me know if you need help or questions.